8.2, day 2, part 1, continuation of multiplying and dividing rational expressions. And then at the very end of this lesson, we are going to solve some rational expressions. The first example, I would say you don't need to write down, just follow along. We have three fractions that are multiplying together. We first want to try to cancel any common factors. So let's look at the 15 and the 20. I can reduce those both by 5. So 15 divided by 5 is 3. 20 divided by 5 is 4. Then I look at the x's. I can cancel an x out of here and an x out of there, so those become 1s. Then I still have 7 x's in the numerator and 4 x's in the denominator, so I can take out a total of 4. Come up with x to the 4th there, and then a 1. I'm just going to rewrite what we have. 1 times x to the 4th times 4 over 3 times 2, can't forget this 2, 1 and 1. Looks like we're going to reduce one more time. 2 and 4. Those become 1s. So our final answer then is 2 times 1 is 2, x to the 4th. 3 times 1 times 1 times 1 is 3. And there's our final answer. All right, here is one that I do want you to write down. We're going to go ahead and simplify this rational expression divided by another rational expression. So if you remember the rule is to keep the first fraction. And then change it to multiplication. And then flip or reciprocate the second fraction. All right, now we have to go ahead and factor those pieces. So let's start at the top of the first fraction. There's a GCF there of x squared. So we're left with x squared minus 9, which we will factor again in a little bit. That's a difference of 2 squareds. Then, in the denominator, that's the T-chart method. So what are the factors of 3 that add to negative 4? Well, that's negative 3, negative 1. So we have negative 3, negative 1. Over here on the top of the second fraction, it's the difference of 2 squareds. So it's x minus 4 and x plus 4. In the denominator, I have a GCF of x squared. So I'm left with x squared plus 2x minus 8. I do have a couple polynomials that we still have to continue factoring. So let's talk about this x squared minus 9. That is the difference of 2 squareds. So it would be x minus 3 and x plus 3. And then we still have that GCF out in front. And the denominator still x minus 3, x minus 1. Multiplication. Then we have the numerator already factored. But we have to take care of this trinomial. This is a T-chart method. What are the factors of negative 8? Then add to 2. Positive 4 times negative 2 adds to 2. So we have that GCF still out in front of x squared. Split up the x's of that trinomial, and then it's plus 4 and minus 2. Now we look to see what we can cancel. Well, we can cancel an x squared and an x squared. We can cancel an x minus 3 and an x minus 3. We can cancel an x plus 4 and an x plus 4. So what we're left with as a single fraction multiplying across x plus 3, x minus 4, over x minus 1, x minus 2. And then the domain restrictions, x cannot equal. If I substitute a 3 into here, if I substitute a 1 into there, I substitute a 0 in there, a negative 4, and a 2. So the domain restrictions would be x cannot be 0, 1, 2, 3, and negative 4. All right, we're going to move on to a new topic. We want to solve these rational equations where we want to solve for x. So we have x squared minus 25 over x minus 5 equals 14. How we solve these is by cross multiplication. And canceling. So I'm just going to show you the steps here quickly, and then I'll work through it. So we want to factor first if we can, and then cross multiply if we can't. So x minus 5, x plus 5 can be factored, so we don't go right to cross multiplication. And now we see what can cancel, the x minus 5's, and now we don't have a fraction anymore, we have a linear equation. So we're left with x plus 5 equals 14, and now we solve by undoing. 14 minus 5 is 9. And then remember the domain restriction, the dr is x cannot be 5. The reason why, if I substitute 5 into there, it would make it undefined. It would make it 0. All right, we're going to go ahead and do one more of these, and then we are, I believe, done with our lesson. So we want to solve this equation. So first check to see if it's factorable. If it's not, then we're going to use cross multiplication. So let's talk about the numerator. The numerator can be factored using the t-chart. What are the factors of negative 10 that add to negative 3? So negative 5 times 2 adds to negative 3. So we split the x's up as x minus 5 and then x plus 2 over x minus 2 equals 7. Did we get anything to cancel out there? Nope. So then we have to use cross multiplication. So I'll show you. There must be a mistake in this original problem. I just noticed. Because this middle term must add to negative 3. I just noticed that I pulled this from a different textbook from online. So we're going to skip this problem or just change this to a plus 3. Then it'll work. So then we would have positive 5 and negative 2. All right. So now we cancel those x minus 2's. We're left with x plus 5 equals 7. 7 minus 5 is 2. And then the domain restriction is where x cannot be 2. So if you really look at the bottom here, because the left side of the original equation is undefined when x equals 2, there's actually no solution here. So sorry about the mistake there. Should have been originally x squared plus 3x minus 10. So there is no solution here because our domain restriction said that x could not be 2. So So again, because the left side of the original equation is undefined when x equals 2, there's no solution. Here's the homework for 8.2, day 2.